projects. In this video, we are going to explain about a project titled Intelligent Ambulance, that is AI and Human Interface Technology. So now coming to the introduction part, the emergence of intelligent ambulances fortified with AI and human interface technology signifies a groundbreaking advancement in emergency medical services. This innovation is poised to redefine the standards of care by fusing cutting-edge technology with compassionate human intervention, ultimately saving lives and elevating the efficiency of emergency medical responses. Through augmented reality displays and wearable devices, paramedics receive crucial information en route, allowing them to prepare for specific medical interventions. This not only streamlines the treatment process but also minimizing errors and enhances the overall quality of care. So now coming to the objective part for this project is to revolutionize emergency medical services by optimizing response times, enhancing medical accuracy, improving communication and ultimately elevating patient outcomes. This innovative concept strives to set new standards for emergency care in an increasingly interconnected world. Furthermore, the intelligent ambulance aims to enhance communication and collaboration among all stakeholders involved in the emergency response process. Human interface technology facilitates real-time information sharing between paramedics, hospitals and other medical professionals. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system is Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. So now coming to the methodology part, first we have upload heart disease dataset. It refers to the process of providing a heart disease dataset to a computer program or system for analysis. This dataset likely contains information about patients, including various attributes that can help predict the presence or absence of heart disease. Second, dataset pre-processing and train test split. So it involves preparing the dataset for analysis. This includes steps such as cleaning the data, that is handling missing values or outliers, etc., transforming categorical variables into numerical representations, and normalizing or scaling the features. After pre-processing, the data set is typically split into two subsets, that is training set and a testing set. The training set is used to train the machine learning algorithms, while the testing set evaluates their performance on unseen data. Third, we have run decision tree algorithm. It involves applying the decision tree algorithms to the pre-processed data set. Decision trees are a type of machine learning model that make decisions based on a sequence of rules learned from the data. Fourth, run random forest algorithm. Run random forest algorithm entails using the random forest algorithm on the data set. Random forest is an ensemble learning technique that constructs multiple decision trees and combines their outputs to make more accurate predictions. Fifth, run KNN algorithm. It involves applying the k nearest neighbor, that is KNN algorithm, to the data set. KNN is a simple but effective algorithm that classifies new data points based on the majority class among the k nearest neighbors in the training set. It measures the similarity between data points using distance matrix. Sixth, comparison graph. It refers to creating a visualization representation that compares the performance of the different algorithms used, decision tree, random forest, and KNN. This graph can showcase metrics such as accuracy, precision, recall, and F1 score on the testing data. Such a graph helps to identify which algorithm performs best for the heart disease prediction task. 7th, receive patient condition to hospital server. It implies that the developed model is ready to be deployed in a real-world scenario. Once the model has been trained and evaluated, it can be integrated with a hospital server or system. When a new patient is provided to the system, the model can predict the likelihood of heart disease based on the patient's attributes and provide this information to the hospital server for further medical evaluation and treatment decisions. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing a .csv file as a dataset. And this is a Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. So now click on upload hard disease dataset button to upload the dataset. Here I am selecting this hard disease dataset and now click on open button to load the file. So here on this screen, you can see that the dataset has been loaded over here, and in this graph here, x-axis represents class labels as zeros, normal, and 1 abnormal, and here y-axis represents counts of dataset records. And now closing this graph, click on dataset pre-processing and train test split button to pre-process the dataset, such as shuffling, normalizing, and splitting datasets into train and test. So here dataset is pre-processed, and we can see 80% dataset used to train algorithms and 20% to test algorithms accuracy. And now click on run decision tree algorithm button to train decision tree for getting the output. So here in this screen, you can see that decision tree training completed, and we got its accuracy as 100%. And we can see other matrix, and in confusion graph matrix, x-axis here represented predicted labels, and here y-axis represents true labels. And here yellow box contains correct prediction count, and blue boxes contains incorrect predictions count. And so now closing this graph, click on run random forest algorithm button to train random forest for getting the output. So here you can see that here on this screen, you can see that we have got the accuracy as 98% over here. And in random forest confusion matrix graph, we can see that over here that the yellow boxes are representing the normal heart rate, and whereas the blue boxes are representing the abnormal heart rate. So here in this graph, you can also see that other matrix, and in confusion graph here x-axis represents predicted labels, and here y-axis represents true class labels. So here true labels and yellow boxes contains correct prediction count, and blue boxes contains incorrect prediction count. And so now closing this graph, now click on run KNN algorithm button to train KNN and for getting the output. So here on this screen, you can see that KNN is getting 88% accuracy. And now closing this graph, click on comparison graph button to get the graph. So here in this graph, you can see that x-axis represents algorithm names over here, and here y-axis represents accuracy. Another matrix in different color bars, and in all algorithms, decision tree and random forest got high accuracy. And so now closing this graph, now click on receive patient condition to hospital server button to start hospital cloud server for getting the output. So here you can see that here in the selected area, you can see that hospital server started, and now start ambulance application by clicking on the run.bat file. So now here you can see that we have another folder which is named as ambulance. In this we have a run.bat file. We have to click on this run.bat file from ambulance folder to get out. So here you can see that we have to click on report patient condition to hospital server button to upload test data, and then ambulance will send data to server to get patient predicted output. So here I have to select this data set, and now click on open button to load the data set. So here on this screen, ambulance sending test data, and then server receiving patient data, and then prediction condition as normal and abnormal, and sending back response to the ambulance. So here you can see continuously ambulance will send patient data to server to get predicted condition, and based on condition doctors will arrange medications over here. So now simply closing this application over here. And so now coming back to the conclusion part. In essence, the intelligent ambulance showcases the immense potential of harmonizing AI and human interface technology to transform emergency medical services into a seamless, responsive and patient-centric system. By embracing this paradigm shift, we are not just embracing technological advancements, but also redefining our commitment to preserving human life with unwavering dedication and expertise. As AI algorithms continuously learn and adapt, and as human responders leverage their expertise, this collaboration holds the promise of safer, more effective and more empathetic emergency medical responses. However, challenges in implementation, data security and ethical considerations must also be addressed to fully realize the potential benefits of this technology.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.